In this video, I'll demonstrate how to use Desmos to perform linear regression. The process would be the same for any other type of regression, except we'd have to adjust features a little bit. So first thing we want to do is insert a table to input our data. And you'll notice that my columns are labeled x1 and y1. We shouldn't change those to x and y because that will conflict with any functions we try to graph on here. It's a strange thing, but nonetheless. So let's just say I have a few ordered pairs. I have the 0.1, 3, and then 2, 7, and you'll see right away that if you're zoomed out far enough, those points will begin to plot. And then let's say I have 3 and maybe 11, and then I have 4 and 15, and I want to plot a linear function. First thing I'll do is kind of squeeze in the x-axis a little bit. So I'll come over here and just change my x max to maybe about 6. That's plenty sufficient. I can kind of adjust my window. Okay, so I see that the data is pretty linear, and I want to fit a linear model to it. Next thing I'll do is I'll come down to a new line, and I will type in basically what I want the function to look like. Anytime I reference x1 and y1, Desmos recognizes that those are values from my table. Anytime I use other letters other than x1, y1, or x and y, Desmos will attempt to estimate those values based on what's known as least squares linear regression. So I will enter y1, and I basically want to say y equals mx plus b. I mean, that's the general form of linear equation. I don't have to use m and b. I could use a and b, or c. It doesn't matter what letters other than x, y, x1, and y1. And instead of doing an equal sign, I have to do a wiggle. It's called the tilde, and for most keyboards, that's left of your one button, your button with the number 1, and you usually have to hit shift and that key. So look for that on your keyboard. So y1 tilde, and next I'm going to type in mx1. Okay, I don't have to do an underscore. I just type x1, and the 1 appears in the subscript, and then I can do plus b. And you'll notice that you'll get stuff appearing as you're typing this in. Ignore that until you're fully done. Okay, so what this does is down here where it says parameters, it's estimating the best values for those parameters. In this case, I guess I did end up picking a perfectly linear function because it tells me that the r-squared value is 1, meaning that's a perfect fit for that data. Again, I could use any letters here. I could use A and W over here, and it will still produce the same estimates, except now A is 4, which is my slope, and W equals -1, which is my vertical intercept. Also, if I came in here and changed a data point, you'll notice that that line changes, right? It's still trying to come up with the best fitting linear model. And in this case, because it's not a perfect fit, it will tell me r-squared is no longer 1. It's about a 95% fit. That's basically it. That's all you need to do in order to do a linear regression in here. If you added other terms in here, it would continue to try to estimate those. But because we're just trying to do a linear function of the form y equals mx plus b, just note that you have to use a tilde here, and you have to use the subscript that's in your table. So if I came down here and inserted a new table, for instance, then you'll notice that my parameters change to x2 and y2. And if I start typing in values for this, you'll notice those appear in different colors so as not to conflict with my table up here. So in that case, if I wanted to fit another linear model, I would have to do down here y2 tilde mx2 plus. I can't use a or w because I see I've used those up there, so I'll just do mx2 plus b. Okay, so in this case, I only have one data point, so it's going to give me some weird things. But there's another point. In this case, because it's 2 points, the line goes perfectly through them, r-squared equals 1. And that's a separate linear model. That's how you do linear regression in Desmos.